work through 4 of the problems, and you should pause the video as you needed to make sure you understand how to do each of these. So we'll do number 1 together. Number 1, you're supposed to factor 8x cubed minus 125. Now the first thing you should see is that there's only 2 terms here. So if there's only 2 terms, then you need to think special pattern of difference of squares, difference of cubes, or sum of cubes. Since you see this x cubed, you should think of the difference of cubes pattern of a cubed minus b cubed, and these should be in your notes, equals a minus b times a squared plus ab plus b cubed. I'm not going to explain this too much because I posted a short video, 2 to 3 minutes, about difference of cubes, and you can watch that to see how exactly to do this. But we see that 8 is a perfect cube of 2, and x cubed is a perfect cube. So a is what we cubed to get 8, and what we cubed to get x cubed, so x. And then b is going to be what we cubed to get 125. That would be 5. So a is before the minus sign, b is after the minus sign. Don't worry that, oh wait, there's a minus sign. Is that -5? No, b is just the number after the minus sign. Now is a squared, so a is 2x. 2 squared is 4. X squared is just x to the second. Then we add the product of 2x and 5, which is 10x. And then we add b squared, which is going to be 25. I see I made a mistake over here. That should be b squared, not b cubed. Sorry about that. That's correct in the video that I posted last week, though. And this is as good as you can do factoring. We have a linear factor, which is degree 1, and we've got a quadratic factor, which is a degree 2. So add those 2 degrees up, 1 and 2, we get degree 3. Makes sense. So now I'll take a look at number 3 on that same worksheet. Number 3, you have 3x to the 4th minus 3. So again, we've got 2 terms, so we should be looking for something cubed or something squared, difference of squares, or one of our difference or sum of cubes patterns. 3 is not a perfect square. It's not a perfect cube either. 4 is not a perfect cube, so we're a little stuck here. But remember, your first step is always factor the GCF, the greatest common factor. So we factor out a 3, and be careful, it's going to be a -1 here, because if you distribute that 3, you should get the original polynomial that you have. Now, is it difference of squares or difference of cubes? We see that this 4 is a perfect square of x squared and x squared. So we're going to factor that to x squared and then x squared. This is a difference of squares pattern. A squared minus b squared equals a minus b times a plus b. And a is what you multiply by itself to get to the first term. So x squared times x squared gives you x to the 4th. And then we've got a -1 and a +1 because that's the square root of 1. And this is a tricky situation. This is something that's very classic in algebra texts and algebra teachers, is they like to have you do a pattern and then think, wait, is there more? And there certainly is. X squared minus 1 is yet again another difference of squares. So you always have to go back and look to see, can I factor more? So x squared minus 1 is going to become x squared minus 1, or x minus 1 times x plus 1. And then we cannot factor x squared plus 1 over the reals. Now notice we started with a degree 4. We've got a degree 1, and degree 2. Add those degrees together, you'll get degree 4. Okay, let's take a look at number 4 then. So I'm just trying to do a few different problems, a few different strategies of the problem types that you see. So we have 6x cubed y plus 15x squared y. So now that we've just got, we just have a bunch of variable terms here and a coefficient, always look for the GCF. So the greatest common factor of 6 and 15 is 3. The greatest common factor of x cubed and x squared is x squared. And the greatest common factor of y and y is y. So you can see what I did is I looked at the greatest common factor of the coefficients, each x term, and each x factor and each y factor. Now what's remaining from this first term, when I factor 3 out of the 6, is a 2. When I factor an x squared out of x cubed, it's an x. When I factor a y out of the y, it's just 1. And then we add. When I factor 3 out of 15, I get 5. When I factor x squared out of x squared, just the 1 remaining. And same thing with the y. So that's all the more you can do with that. Now in some of the other ones later in the sheet, what you end up factoring here in this binomial might now become a special pattern or a trinomial or something like that where you need to factor more. So always take a look to see whatever you factor, can we factor it further? And lastly, I'll do number 8 for you on this worksheet. Number 8, we have a 4-term polynomial. So this will be a little bit of factoring by grouping. That's your immediate instinct, or at least what it should be once you get enough practice with this. So we're going to factor the first two. Take out the GCF. So we get x squared. When I factor an x squared of x cubed, there's x. When I factor an x squared of 2x squared, it's just 2 minus. Now we've got a minus 9x and a plus 18. Typically what we will try to do is factor out the number so that this x term is positive. So since this is a minus 9x, I'm going to factor out a negative 9. And then I'll just have an x inside the parentheses. Whereas if I just factored out a plus 9, then I'd have a negative x inside the parentheses, and we typically don't like that. So try to keep that x term inside the parentheses positive. And when I factor negative 9 out of a positive 18, I get minus 2. And you'll know you're doing this right, hopefully, when you see a common factor from each of these two new terms. They each have an x minus 2, so I'm going to factor out the x minus 2, and then what's remaining in this first term is an x squared, and what's remaining in the second one is a minus 9. So that would be factoring by grouping, and that would be great if that's all there was to it in this problem. But remember what I said, algebra texts, algebra problems, algebra teachers like to make you loop back and say, wait a second, I've got this 2-term polynomial, a binomial, and it's a difference of squares. So it's going to be x minus 2 times x minus 3, x plus 3. You won't always have that, but it's going to happen enough where it should just be second nature for you that you always check to see, can I factor those quadratics further? That's what you're looking for. So what you need to do now is pause and try some more of those problems on that Factor All Completely worksheet. And then what I'm going to do for the remainder of the video is show you how we're going to apply this. Okay, so the whole point of factoring, remember, is to get intercepts. So we're trying to find intercepts. Real zeros are x-intercepts, and then complex zeros won't give us intercepts at all, but they're still zeros. So if I give you guys the problem, 2x cubed minus 6x squared plus 2x minus 6. And suppose that equals y, so I'm trying to graph this. What I'm really interested in are the key features of the graph, and one of the most important key features are the x-intercepts. So the x-intercepts are where you set y equal to 0 and you solve for x. So I'm going to set y equal to 0. And in order to do this with something equal to 0, there's so many different things x could be, I'm not going to randomly guess. However, if I've got a product of things that equal 0, it's really easy to know that one of them equals 0. That's what the zero product property says. So the first thing, factor. I'm going to get rid of the GCF. Always look for the GCF first. That's a little tricky because you might be thinking right away, it's a 4-term polynomial, so factor by grouping, and you're right, that would work, but get rid of the GCF. Now what we're going to do is we're going to look at those two together, and we'll look at these two together. So we still have this whole 2 and parentheses. I'm going to give myself a little bit more space. But when I'm factoring out what I bracketed in red, that's going to be x squared times x minus 3, again, using the factoring by grouping technique. And then when I look at what I have in black, there's nothing there to factor out. It's just going to be an x minus 3. Now, that's kind of tricky because it doesn't look like there's 2 factors there. So what I'm going to do is put that in parentheses so it matches what I have in red, and just put a times 1 in front, because when I multiply by 1, that changes nothing. So now what I'm going to have is my GCF. And then now each of these, I'll do this in green, x minus 3 is an x minus 3. And then what's remaining in this first term inside those blue parentheses is x squared. And what's remaining in the second term is the plus 1. So that's the really big advantage of writing that 1 there, so you don't forget that second term in this binomial. And that equals 0. So what we just did is we factored this cubic into the greatest common factor, which is no big deal, that's just 2. Then this linear term, x minus 3. And then this quadratic term, x squared plus 1. What we need to do is say, can we factor this further? And we can't. That's just going to be x squared plus 1. That's a sum of squares. Can't factor that. So using the zero product property, we know x minus 3 equals 0, or x squared plus 1 equals 0. Solving this, we get x equals 3. So 3 comma 0 is an x-intercept. Doing this, we get x equals plus or minus I. You should work that out yourself to see how that shows up. However, these are both imaginary zeros, and they're conjugates, as you see, so they're not going to show up as x-intercepts. So what we just found out is this degree 3 polynomial has 1 real 0 and 2 imaginary zeros. So that's how we would work that one out. Now we could do that a little bit further, and I'll do one more example just so you guys can see that with a little bit different view. But with this, hopefully that's enough to start the worksheet. Okay, last one. If the previous examples weren't enough, we'll go a little bit further. So suppose I have x to the 4th plus 6x squared plus 5 equals y. So we'll set equal to 0 for the zero product property. And to find your zeros. Well, when you've got a trinomial, we're going to factor it like we've factored before. But now instead of x and x, we're using x squared and x squared because we need that x squared middle term. Both signs have to be the same because it's plus 5, and both signs have to be positive because it's plus 6. So this is the only way this quartic can factor. X squared plus 5, x squared plus 1. So either x squared plus 5 equals 0, or x squared plus 1 equals 0. Now if you solve this, we get x equals plus or minus the square root of 5i. And this is x equals plus or minus I. We have 4 zeros because the fundamental theorem of algebra tells us degree 4 has 4 zeros. However, these zeros here are imaginary, plus or minus, they're conjugates. These zeros here are imaginary, they're also conjugates. So what this is telling me is the polynomial x to the 4th plus 6x squared plus 5 has no x-intercepts. All of its zeros are imaginary or complex. Either way, it doesn't matter. It's never going to cross the x-axis. So this should lead you enough to be able to tackle many of the problems on the Chapter 5 Factor Polynomials worksheet. Do the best you can on that. We'll take a look at it for a little bit of the class period tomorrow.